Hey, it's Mr. Zalatano, and this video is going to explain balancing chemical equations, and it's going to be part one of a couple of videos to help you learn tricks to balance. Okay, so first thing, here is a chemical equation that's already balanced, just to show you an example. Remember that Antoine Lavoisier said that matter can't be created or destroyed, but only rearranged. So if we check the left side of this arrow, in other words the reactants before the chemical reaction, we have a certain number of each type of atom. So if we were to check, on the left side, we've got 1 black, which is carbon, 4 white, which is hydrogen, and 4 red for oxygen. Now, according to that, Lavoisier's conservation of matter, essentially, we would know that after the chemical reaction, nothing was lost or gained. All of the atoms we started with on the left side must be there after the reaction to make the new chemicals on the right side. They just rearrange themselves to make different chemicals, but they're all still there. All the building blocks that we began with, all those Lego pieces are still there. They just are built into different things. So we would check that, and on the right side, and notice I put an equal sign here and underlined equations, because a chemical equation is just like a math equation. It's just that we use an arrow to indicate our equal sign in chemistry instead of an equal sign. But both sides should be equal. And that's sort of the goal of balancing the equation, is to make both sides equal. So on the right side of the arrow, we also have 1 black for carbon, 4 white for hydrogen, and 4 red for oxygen. So that's how we know it's balanced. Balancing equations is all about balancing the atoms. We should have the same number of atoms on both sides. Okay, so as a little bit of terminology, we have a subscript. That's the number that goes after an element in a formula to indicate the number of that element that is chemically bound or stuck to the chemical. So in H2O, which we have a molecule of it right here, there are 2 hydrogens that are chemically attached. That's why that number is written down below. And there's an invisible 1 oxygen that's also chemically attached. So a subscript means that it's part of the overall chemical. They're chemically bound together. And that's very different from a coefficient. A coefficient goes in front of the entire chemical, and it multiplies the entire chemical. So for example, if we put a 2 in front of this H2O, we are saying that we have 2 separate H2O molecules. They are not bound together. 2 in front, or a number in front, is multiplying the entire chemical. And what that's also going to mean is we're going to multiply how many of each thing we have, right? So 2 times 2 is going to give us a total of 4 hydrogens, so we have 4 white atoms there. That makes sense. And 2 times 1, the invisible 1 there, is going to give us a total of 2 of our red oxygens. So very different things, coefficients and subscripts. So here's an example of an unbalanced chemical equation. This video is going to start to give you some tricks to help you become faster at balancing, but just realize that it's going to get messier before it gets better, and it's going to be a struggle at first. It's going to have to guess and check. It's going to be a little bit of trial and error. It is a skill, and by the time you get these practice skills down, you'll be able to do it much faster and without error. But for now, there's nothing wrong with trying, getting it wrong, erasing, and kind of starting over. Okay, so this first skill for this one, first of all, let's learn how to organize our atoms. So I like to use the tic-tac-toe board. And so what that means is just below the arrow, I put my tic-tac-toe board. And I want to get an inventory. I want to know how many of each atom we have to start with, so we know sometimes you're already balanced. So we'll see what we need to do if it's balanced or not. So we just do 1 of each element. So P is in there, O is there. Those are only 2 elements present. Again, we're just trying to balance the atoms. So we're focusing on just P's and O's separately in this one. And on the left side, we have a total of 4 P's. And on the right side, we have 2 P's. On the left side, we have 2 O's. And on the right side, we have 3 O's. Pause the video at any time if it's going too fast, or you need to double check to see if that's accurate. This skill we're looking at is called the 2-3 swap. So in some chemical equations, there will be a 2 following a certain element, and on the other side of the arrow, there will be a 3 following that same element. If that's the case, which doesn't happen all the time, we can do something called the 2-3 swap, where we can put a 3 in front of the guy that has a 2 there to multiply to get to 6, and we could put a 2 in front of the guy that has the 3 there to multiply to get to 6. So I put a 2 here first to try to balance, and what that means is I'm going to put 2 times the P, and also 2 times the O. So don't forget, a coefficient multiplies that entire chemical. So a 2 times our 2 P's is going to get us 4 P's, and a 2 times our 3 oxygens will get us 6 oxygens. So you always want to think it's multiplying just the way those arrows just went. So we're one step closer to balancing, right? Our P's are now balanced. And we said this is a 2-3 swap, so we can now put a 3 in front of this O2, and a 3 times a 2 will get us 6, and we're balanced because we have an equal number of P's on both sides, equal number of O's on both sides. Okay, another example of that. We set up our inventory. In this case, we have Fe, which is iron, and O. Those are our only types of atoms present. And on the left side, we have 1 iron. On the right side, we have 2. On the left side, we have 2 oxygens. And on the right side, we have 3 oxygens. Can you spot the 2-3 swap? I feel like Dora the Explorer. So the 2-3 swap here is there's a 2 here and a 3 there on the other oxygen. So that means that we can put a 2 in front of this guy, right? But don't forget, it's going to multiply the whole chemical. So 2 times 2 irons is going to get us 4 iron. So this arrow is actually pointing at that 2 down there. And then 2 times our 3 oxygens is going to get us 6 oxygens. So this arrow is pointing at the 3 there. So we have to fully adjust all that. Okay, so this actually looks like it got messier, right? And sometimes that happens. It looks like it got messier before we can get there. It seems like we're less balanced than ever. But again, this is the 2-3 swap. So we can put a 3 in front of that guy. And it multiplies times the 2. So that's going to get us 6 oxygens. And what should be our final step to balance? Well, we put a 4 in front of the iron. And that should get us 4 irons there. And now we're balanced. We have equal number of iron and oxygen. Okay, another skill that you can use. So sometimes you'll have a polyatomic, right? We've dealt with polyatomics. They're in parentheses there. And one thing that you can do is you can take the number outside the parentheses and distribute it in just like we're in math. So we can kind of see up here the 2 outside multiplied by the 3 gives us 6 oxygens. And the 2 outside multiplied by the n gives us 2 n's. It only applies to what's in the parentheses, just like in math. So it only applies to what's in the parentheses. So for this problem, we've got Al2SO4 with a 3 outside. What could this chemical become in order to make it easy for ourselves? Well, the 3 times the 4 would give us 12 O's, and the 3 times the indivisible 1s will give us 3 s's. So we can make this easier and just cross this out and rewrite it to make it easier on ourselves. Alright, so let's take our inventory now. We have an Al. Right, so we have an Al there that looks like an I, but it's actually an L. So we have our aluminum. We have our bromine, our other capital letter, our potassium, K, our sulfur, S, and our oxygen, O. And that accounts for all of our different elements present. Alright, so on the left side, we have 1 aluminum. On the right side, we've got 2. On the left side, we've got 3 bromines. On the right side, we've got 1 bromine. On the left side, we've got 2 potassium. On the right side, we've got 1. On the left side, we've got 1 sulfur. And on the right side, we've got 3. On the left side, we've got 4 oxygens. And on the right side, we've got 12. There's no exact order to go in. So I'm personally going to start with aluminum, but you can start with whichever element you want. Just sometimes if it doesn't work when you start with that element, maybe when you start over, try starting with a different element. So I'm going to try starting with the aluminum. Aluminum has 2 on the right side and 1 on the left side, so I need to multiply the one on the left side by 2. So that's going to make that 2 aluminum on the left, but I also have to remember that 2 times a 3 is going to give us 6 bromine, so that's going to change things. So now I'm going to say, well, I kind of want to fix the bromines now, so I'm going to put a 6 on the right side, because 6 times that 1 bromine will get me 6. But that will also change the K, the potassium, right? So now potassium is also 6. Looks like it's getting kind of messier. Now I'm going to try to balance my sulfurs. So I'm going to go ahead and put a 3, because 3 times the 1 here is going to get me to that 3, just like what's on the right side. Oh, and so when I do that, actually, we could also try to balance the potassiums too. So 3 times the 2 is going to give us 6 potassium. 3 times the 1 sulfur is going to give us 3 sulfur. And 3 times the 4 oxygens is going to get us 12 oxygens. And now we're actually balanced. So it's okay to have a blank. Sometimes you'll have a blank. That is perfectly fine. In fact, often you'll have a blank. It feels uncomfortable, but this is balanced without actually putting a number in that last spot. Now, if we were to rewind a little bit, some people will not need to actually rewrite this formula. Some people will see, okay, on the left side, I've got, let's see, on the left side, I've got SO4, one of them, and on the right side, I've got 3 SO4s. So I'm going to go ahead and put a 3 in front of here, and then they'll balance that way. It depends how you see it. But so this was part 1 of our skills for balancing equations. Thanks for watching, and remember, chemistry is everywhere.